Dr. Grissom, and today we're going to be discussing Lab 1. And to start us off, I'm going to go backwards with Challenge 2 because I have that plugged in right now, as that one took way longer than Challenge 1. About 6 hours. So, yep. Alright, let's begin. So, first for our library, we want to include the Adafruit Seesaw, which is for our gaming controller. And then the first thing we want to do is to initialize that gamepad, which again, we have this object that lets the actual device, the M5 Core 2, communicate to the gamepad, which is what we need. And then we pass through the wire, which again, need for to connect that gamepad. And then here we have the I2 settings, which luckily on that chart and on the actual PDF we could click from, we can see all those what they connect to. So the SD and SCL 3233, which is usual. And then we have the game address, which is at hexa 0x50. And thanks Google for telling us that address at the gamepad. And then we have our gamepad button pins, which each pin number comes from the Adafruit Gamepad QT, which is a guide I looked up and then I found them, which you define each of them, which is all of those buttons. And then you combine all 6 buttons into the value which is necessary because the gamepad has 6 buttons and we want those all to work at the same time. So that's what this is. And then we do the joystick settings, which allows us to use analog pin 14 and 15, which again you can be found on the actual guide. And then you can rotate the joystick normally. That resets the 0 round, which would be 512, which scares the 0 to 1023, which again 512. And then we did the dead zone, which you don't want too much dead zone, but not too little, so it just resets to the center there. And then the screen size, which we talked about before, radius, pretty simple. It's just 8, not too big. And then creating the blue dots and their positions. I chose it similar to how a ping pong game was back then, where you have the 2 bars. I looked up those positions, and then I was reading it was at 60, 120, and then 260, 120. So I just picked those. And so yeah, just used for this game. I used a very old game from the arcade, so I think that's kind of ironic. And then now to erase those old dots, which again you don't want to always keep it because since they're constantly moving. And then you could do the actual speed, which the initial speed I did is 2 because you don't want it to be too fast or too slow, which I think 2 is pretty fair. And then maximum speed is 6. And then after this, the speed can repeat. And this part kind of confused me, so I had to look it up and kind of had AI explaining to me how that actually works. Which it makes sense now that you use a boolean to tell us if it's falsely pressed or if it's actually pressed, which you get false. And then the next thing you did is the game timer, and that stores the time when the game begins, so you can bet better each time. And this also adds replayability to the game. And then it becomes true when the dots actually collide, and now you get a game over. And then for the speed info, again, you just do draw speed, M5 LCD, and you just input all this. Again, this is stuff we've done from similar to phase 1, so I'm not going to talk about that too much. Then you keep a dot inside this, and then you have to keep the dot inside the screen, which again stops the dot from leaving from the left side, right side, speed side, and then leaving from the bottom. So you always have to account for all those. I also had to look that up because there's just too many directions, and you don't want it to be able to easily break your game. And then now you have to do the collision. The collision physics is very annoying. Then you have to basically declare the integer, and then I minused it by the red X, and then blue minus red. So basically, if those hit each other, and then the vertical and horizontal alignment, and then you calculate the actual square distance between the centers, which I looked up the equation because I was very confused at that point. And then you collide those distance between them, which then dot radius multiplied by 2, and then you can just return it, which that made sense to me. And then after that, you display the game over screen, which again, if you get a game over, you're going to get to true. And then you calculate how long the game lasted, which is a challenge for the game. And then after that, you clear the game over screen and you display the game over message. And then you display the elapsed time. And after that, again, to set up, again, you begin serial monitor. We already went over a lot of this. I'm just going to skip over that. Then you draw the starting dots, begin the game timer, the loop runs repeatedly. Again, for game over, you're just going to keep constantly see it. There's no way to only do it, so you have to hard reset the device. And then you read the controller, which you need a lot of document. I needed a lot of documentation to understand this part because uh, getting a basic controller work was very confusing. So then you do each joystick X, then Y, and then you pass in the pin and the Y pin, and then the unsigned buttons, and then you the mask, and then the Boolean, and then this B button reads when low is pressed, X, Y. You just repeat this same process till you do all the buttons, and then you save the current position before moving, which is just equals blue X, old blue, and then old red, Y. And then you move the blue left, move the blue right, move blue up. This is just the physics of moving blue. And then guess what? You gotta do it for red. Then move the red dots using the actual D-pad. And then after that, you can increase the blue speed once the start is pressed. Increase the red speed once select is pressed. And then you save the current button for the next loop. And then after that, you keep the dots inside the screen, which is pretty simple. You just pass these through. And then you erase the old dots, which again was confusing, but again it makes it because you have to move each pixel by one, so you're erasing that dot each time you move in a way. And then you fill that circle, and then you only erase and redraw red if the same, and you do the same with blue, which again, as you can see, same with red, and then same with blue, and then check for a collision, and now we have our game over screen, and it's game over. If they've collided now, just display game over, pretty simple. And again, you don't want to delay it too much, but you don't want to delay it also none to where it would just keep flickering. So I think 16 is a good bar for finicky, and the game is basically complete. But again, we don't have like a start screen or any of that. But I mean, that was already a lot of code for just the basic functionality. So I think that wraps up the gaming one. And then I will just go over the other one too. Then the challenge one was to make a speaker, which we have our variables, and then this basically again pins. We talked about that, proximity values while testing the sensor. Highest which I could get 420 was the touch of my head, so I made the closest reading be able to be 420, and then use the control. I use the control when the beep and vibration switch on and off because this can get really annoying. And it actually fell off my desk, so to keep the binary off, I just kept it to 0. The vibration off, I kept it to 0. And then I used this to create the sound, which I got these values from documentation. Again, pitch sound, and then again just the buffer sound, and then you define your register devices. Already done in class, so I copy and pasted those, and then I created a square sound wave that again requested frequency. You could tell it also had some help with AI to do a square wave, and then I had to figure out how to get the M5 Core 2 to play it, which again, play tone, then it halves the sound wave, which I found out because of research, and then I prevented the division or time problems, which I did not know with sound that we were going to run into these issues because of each pitch, so I also had to look up, you have to actually equate one to the half wave and then the far wave. And then after that, you fill the sound buffer with positive or negative values. Again, positive means you go up in pitch, minus means you goes down. So pretty simple there. And then I created a sound. Then after the created sound, it's pretty simple. You just send it to the Core 2 speaker, which play sound. And then you begin. Pretty simple. Then make sure the vibration motor started to turn off. Again, very annoying. This vibration motor. Connects to the I2C, which I did happen, and then enable the proximity sensor, which we already did, so I just stole that, and I did all that. And then starting the time zone beeps can be super annoying. Again, you just equate it to the millis, which we've already done in phase 1, I believe. Then void loop, we want to make sure we can read the proximity value directly to the VNCL 4040, and then keep the proximity value to 0 and 420 max, and then converts that proximity into the actual pitch, which is the 2000. And then after that, the beep interval, switch the sound and vibration when time has passed, and while outputs are on, play the tone, and then print the information on the serial monitor to tell me if it's actually working. this one was a lot easier than the gaming one. The gaming one I had to look up so much. It took almost 6 hours. This one took almost, probably like 4. So other than that, I think that wraps it up. Um, I will be sending 2 videos. One of the gaming controller working with the LCD screen, and the other with the proximity. The closer you get, it beeps and vibrates. I think that wraps it up for Lab 1. Thank you.